Hello again, this is Professor Lee. We are continue to investigate this probability chapter, right? So today we are going to check 3.3 and we are basically going to check two rules. But you know what? These two rules are not really something new, right? This is one that we already know, right? So this is going to be relatively shorter chapters, right? So let's start. So we are going to talk about basically multiplication rule and addition rule. But these two rules, like I said, it's just we are summarizing these two rules in this chapter, but this is nothing that's really new. So let's talk about multiplication rule first, right? Multiplication rule. So multiplication rule is, it looks like this: probability of A and B. So you might want to link multiplication rule to AND, right? Multiplication rule is about AND in the middle, probability of A and B. And as we checked in the last chapter, and we can also rewrite with this symbol, right? It looks like, AND, right? Like that. So this means AND. So we are going to consider two separate cases when it comes to probability of A and B. If these two events are dependent case or independent case, right? We just need to consider these two cases. Now let's do independent first because it's easier. If these two events are independent, meaning what? If you remember last chapter, independent means these two events, they don't interfere with each other, right? And another key word that we can also remember for being independent was what? With replacement. With replacement, it's not always the case, but whenever always the case that independent question always have this word, but whenever that we have this word with replacement, we can assure that we are dealing with independent case. So whenever that you see with replacement, then you know that you are dealing with independent case. So what if we are dealing with this independent case? Then what? Then when you can calculate probability of A and B, all you need to do is just simple multiplication between these two. I mean, there's a missing dot there, but it's just saying probability of A times probability of B. And that's when you have these two events, they are independent event. Now, if they are dependent event, then the another word that we see is without replacement. Whenever that we see without replacement, that means we are dealing with dependent case. If they are dependent case, how do you calculate probability of A and B? Well, you calculate it like that. Probability of A times probability of B given A. We have to have this condition, given A. But, as you can see, this is not the only way to do this. We can also do it this way. Why? Because, in a way, you are looking at this as this. This is probability of B and A. Is this the same thing? Yes. I told you in last chapter, probability of A and B, probability of B and A, they are the same thing. So if that's the case, Then how do you calculate that? Well, as you can see, it's right here. Probability of B, the first one, and probability of A, which is the second one, but we have a condition. What's the condition? B has to happen first, or at least within B that we are dealing with this, right? So we have these two separate, but still the same formula for figuring out probability of A and B, and these are for dependent case. Now, why would we say this is multiplication rule though? Why do we say this is a multiplication rule? Because at the end, these are just this times this times this, right? And also here, probability of A and B, this is this times this. These are all multiplication based. That's why we are saying this is a multiplication rule, right? That's why we are saying this is a multiplication rule. Okay. Now let's talk about this addition rule here. Addition rule. Addition rule is OR. Addition rule is OR. So how do we consider this OR addition rule? When we have the linking word as OR, you can also rewrite it as this U-shaped mathematical symbols, right? A or B, you can write it like that. And if A and B are defined on a sample space, then how do you say A or B? Well, basically you use this formula right here. So do we always use this formula? Yes. I mean, does it matter whether it's dependent, independent? Remember, dependent, independent is not related concept with OR, the OR rule. Dependent, independent was related concept with multiplication rule, and the linking word was AND. This OR rule is multiplication rule. It's the related concept is actually mutually exclusive, right? Mutually exclusive. So let's go back a little bit. Addition rule means when we are trying to figure out this probability. What is this? What do you mean by this probability? Probability of A or B, right? When we try to figure out the probability of A or B, then we apply addition rule. Let me repeat that again because what I just said is very important. When we try to figure out the probability of A or B, we apply addition rule. What about A and B? Well, A and B was multiplication rule, remember? But when we try to figure out probability of A or B, we use addition rule. So what's addition rule? Addition rule is this rule that I just boxed up, right? This rule is addition rule. Whenever that we are dealing with A or B, we use this rule. As you can see, this is addition right there. So how do I figure out the probability of A or B? You add probability of A plus probability of B. However, you are going to subtract probability of A and B once, just like that. Remember, if these two events are mutually exclusive events also means probability of A and B are equal 0. I mean, it says right here. Mutually exclusive by definition means, mutually exclusive means you cannot be both at the same time. So how can you be in A and B at the same time if they are separate? They are far away from each other. that you cannot be both at the same time. That's being mutually exclusive. So mutually exclusive means this probability A and B must be equal to 0, which means this part is just going to be 0 if you are dealing with mutually exclusive case. So, I mean, you have this separate formula here for mutually exclusive, but you can still use this old formula, the previous formula. It's just that this part is just going to be 0 because if they are mutually exclusive, probability of A and B is just going to be 0, just like that, right? So this is the general rule, mutually exclusive or not, we can use for probability of A or B, but we know that if it's a mutually exclusive, this second part right here is just going to be 0, so you end up having this little bit shorter formula right here, right, if they are mutually exclusive, because that part is just going to be equal to 0. And this is what? Addition rule. So addition rule, when do we apply addition rule? When the question is asking us to find the probability of A or B, or question, right? So I mean, it says it right here, but let me write it again, or, right? Addition rule. When we try to figure out the or question, then we apply this rule. All right, let's try this this example. Now, one is trying to choose where to go on vacation, and he has two choices. Either he want to go to New Zealand, or he could try to go to Alaska, right? I guess he's like nature kind of guy, right? I guess, right? New Zealand and Alaska, right? Now, he can only afford one vacation, and probability of choosing A, but you know what? What does that really mean right here? He can only afford one vacation, right? What does that really mean? I mean, maybe it means he's not super rich. However, this means he is not going to go to New Zealand and Alaska at the same time. He's not going to do that. He can either go to Alaska or New Zealand, one of them. That means you cannot go to New Zealand, Alaska at the same time. So that means these two events, going to New Zealand, going to Alaska, these two events are what? These two events are mutually exclusive event. Because you're not going to go, both at the same time. So that's what this sentence is indirectly saying, that you are not going to go A and B at the same time. So probability of going to A, which is New Zealand, is 60%. Probability that he's going to go to Alaska is 35% right here. Okay? So, well, let's analyze this situation. We know the probability of going to New Zealand and Alaska to place is just going to be 0. Why? Because he says he's not going to afford to go to two vacations. He's only going to go to one of vacation. I mean, it says it right here, but from the questions. So, what's the probability that he's going to go one of this? New Zealand or Alaska. Remember, this is or Alaska. That means probability of A plus probability of B. Why? We go back to the or question. Or question is what rule? Addition rule. So what do? You add, right? You add and subtract the A and B as well. But we know that A and B is equal to 0, so you don't need to worry about that. So it's just a simple addition. So 60%, 35%, 95%. So, it's not 100%, then what's happening? Then, 1 minus 0.95 is 5% chance that it's not going to go anywhere. It's not going to go to New Zealand. It's not going to go to Alaska. There's 5% chance you'll probably stay home, right? Okay. Let's consider this example. A student goes to library and let this event be a student check out one book, and let event D as, I guess B for book, right? D for his student, the student checking out one DVD, D for DVD, right? Suppose that the chance that probability that it's going to check out one book is 40%, 0.4. Suppose that the student is going to check out DVD is 30%, right? Wow. Now let's take a look at this and let's try to interpret this. What does that mean? Students is probably the students checking out the DVD is going to check out the one DVD by her condition. That student already decide to check out one book. That's what this means, because this is given, right? This is conditional probability. So the student is checking out DVD, but there's a condition. Student is checking out books, right? So, when you check out things, you tend to check out few stuff, right? So I guess this probability that a student is checking out a DVD, given that the student is checking out a book, is 50% right there. So question is saying, find the probability of B and D. And also question is saying, find the probability of B or D. Now, let me give a little bit of time. All right? Let me give a little bit of time. Why don't you just go ahead and try this? Because, mathematics is not a spectator sport. When you're watching me do it, it makes a lot of sense, right? But when you have to do it by yourself on your own, that's a whole different story. It happened to me, it'll happen to you, right? When I was like sitting at your place, watching my professor doing stuff, it made a lot of sense, right? But when I'm trying to do it by myself, as a homework or whatever, it was very, very different. It was very confusing. And I'm sure that will happen to you, right? Or it's happening now, probably. But still, okay, try it. And was what? And was multiplication, right? Multiplication. So does that mean that these two events are dependent, independent, or something like that, right? Something like that. Okay. So, and what about or? We have to use the addition rule, right? So let me give you a little bit of time. Why don't you go ahead? Right. Okay. Please don't just sit there and do nothing. Why don't you try it right now? Right? Why don't you try it right now? Okay. All right. So let's see. Probability of B and D. this. We can rewrite that as probability of B and D. This must be equal to probability of B times probability of D given B, right? Why? Because of that multiplication rule and right here. Probability of A and B was what? Probability of A times probability of B given A, right? In that order, right? The first one first, and second one is going here, given the first one. So when we are dealing with probability of B and D, oh, sorry about that. That should be not B, that should be D. So probability of B and D would be probability of B, the first one, times probability of D, the second one, given the first one. We have all this though, right? Probability of B is what? Right here, 0.4. 40, okay. Times probability of B given D right here, 0.50, right there. So if you type it in, 0.4 times 0.5, 0.20, 20%. It's right here, but I'm just rewriting. So that's it. That's the answer for the first question. I think this is a good quiz question, right? Don't you agree, right? Find this. That means probability of B or D. According to the or, that formula. Let me go back to the or right here. This is the formula right here, right? Probability of A or B was probability of A plus probability of B minus probability of A and B. So, this would be probability of B plus probability of D minus probability of B and D. So probability of B, it says right here, but probability of B is what? Right here. That's a 0.40 plus. Probability of D is what? Right here, 0.30 minus probability of A, B, and D. Where's probability of B and D? Well, we just got it from the previous example question right here, 0.20. So 0.4, 0.3, that's 0.7 minus 0.2, 0.5. 0.50 right there, right? So not too crazy, right? Not too crazy. I think this is definitely possible question for us, right? Okay. Now let's talk about this one. This one is also a very good example. So a lot of portable radio contains 15 good radio and 3 bad one. So you have 15 good one and 3 bad one. So altogether how many? I guess altogether 18, right? You have 15 good one and 3 bad one. Now, you are going to pick 2. 2 are selected and tested. Ooh, look at this. Without replacement. Now, we've seen this one before. Without replacement. Now, what does that refers to? Without replacement. Now, let me go back. Right here. Without replacement, meaning these 2 events are what? Dependent event, right? Without replacement, that means these are dependent event. So when we are considering A and B, we are going to use this conditional probability stuff, right? Conditional probability. So dependent event without replacement. Why is it dependent? Because, if you don't put it back, what you pick for the first one matters when you are picking for the second one, right? That's why. Okay, let's try this. You are picking 2. What's the probability that you are picking both bad one, right? Both bad one. And the next question would be, what's the probability that both will be a good one? They say, write your final answer with a decimal, right? Somehow Siri is like reacting. Anyway, write your final answer in decimal with the 3 decimal place, right? Okay, so again, let me give a little bit of time. Think about what you should do, right? This is both means the first one and the second one. This is an and question, right? If it's an and question, it's a multiplication rule applied. If it's a multiplication, then we need to consider whether this is dependent or independent. But the keyword says without replacement, so that must be dependent case, right? Dependent case. Okay, so we want both to be defective, bad and bad, right? All right, so we give it a little time, right? Think about it. If you're watching me do it, it will make a lot of sense. But if you have to do it on your own, that's a different story, right? All right, all right. Okay. So we have 15 good one and 3 bad one. Altogether, it's going to be 18, right? 15 good, 3 bad, 18 altogether. I guess I should put S. So the first part says both bad. That means the first one is bad and second one is bad. So if you apply that conditional probability actual formula, it will be probability that first one bad and second one bad. This is probability of first one bad times probability of second one bad given that first one bad, right? That's the proper, and conditional probability formula. So what's the probability that first one is going to be bad? Well, at the moment, out of total 18, how many of them are bad? 3. So it'll be 3 out of 18, just like this. That's this part. Right? What about this? What does it say? Second one is going to be bad, but we have a condition. What's the condition? First one that you choose is going to be the bad one, and you're not putting it back. Why? Not because it says without replacement. So if the first one is bad, how many bad ones left? You have 2 bad ones left. Out of total, how many? Do you still have 18? No, because you hold on to the first one. Now you have 17 altogether. So you multiply these 2 top, which is 6. You multiply 18 times 17, you get this. 6 divided by 306, then you get this, right? They say you round it up at the 3rd decimal. So 6 divided 306, the you know, actual number that I got is this 0.0196078 and goes on, right? Now, when they say 3 decimal place, that means they cut it right here. Look at this number. That's a bigger than 5, right? 5 or bigger. That'll add 1 to this number. But that's already 9, so that turns out to be 0.020, right? That's our final answer right there. Now that we know this is the case, let's try the second one. Second one said it has to be good and good. Again, let me give you a little bit of time. You know, now that we have A, I think it's a little bit easier for us to do the B. Right? So let me give you a little bit of time to try this. You know, I urge you to try it, right, with me. And you have to be proactive when you're studying this. Because, you know, because it's a challenging course, and this is a challenging situation. If you just sit there, it's just lying down in your bed and watching me do it, that's not going to do the job, right? I'll tell you, that's not going to get you past, right? I'm sorry to break the news, but you need to study to pass this course, right? And I sincerely want everyone to pass, right? I really hope everyone pass. So you gotta work with me, right? You know, it's already chapter 3, right? We are moving fast. So I really want you to, you know, get yourself together and catch up if you need to before it's too late. Soon it'll be too late, right? Soon it'll go really far beyond that. So, you know, if you haven't really pushed yourself, you really gotta do it, right? Okay, so let's try this. Let's verify this. The first one is good, and the second one is good. That means, what's the probability the first one is good? You have 15 good one out of 18 total. But, you know, if I rewrite this, this is probability of the first one is good, and the second one is good. That means probability of the first good one times probability of second one is good, but we have a condition. First one has to be good one too. Okay, then what's this probability? What's the probability that when you pick the first one, it's gotta be good? We have 15 good one out of 18 altogether. Now remember, I'm holding on to the good one because the question says without replacement. So what's the probability the second one is going to be? How many good one left? Because the condition says the first one is a good one. Now we have 14 good one left. How many altogether left? Well, 17 altogether left, because I know that I'm holding on to first one, which is a good one. So altogether is 17 left. That's why we have this, right? That's why we have this. So multiply these together, put it right here. Multiply these together, put it right here. So let me do 210 divided by 306. Now, calculator says 0.686274 ... I'm cutting right there. This number is less than 5. I'm going to drop all together. And this is our final answer. Just like that. Right? So, you know, this would be a good quiz question as well, right? This would be a good quiz question as well. Okay, let's try one more. IRS, right? Internal Revenue Service. Auditor randomly select 3 tax return without what? Without replacement from altogether 61 return that contains 9 of them that has error. What? What's going on? What? Altogether, it's going to be 61 altogether. But out of that 61, how many of them have a problem? 9 of them that contains mistake and problems. So total 61. No error is 53. And the one with the error is 9, right? It says 9. So altogether, when you add it, it's gotta be add up to 61. Now, how many are you picking? You are picking 3 this time, right? And it says what? Without replacement. And we want to write our answer with the percent with 1 decimal, right? Percent with 1 decimal. Okay, so what's the probability that none of those contain error, right? None of them, none of those 3. So that means the first one is going to be no error. So when you pick the first one, it's gotta be, you know what, let me post this. You know, I posted, I found the mistake. This one right here, that's not 53, right? This is 52, right? 52. So when you when you add it, it's going to add up to 61, right? So, you know, make sure that this is 52. So we have out of 61 total, we have first one to be good one is we have 52 good ones. But when I'm picking my second one, it has to be good one too. And because I picked one of the good one, now I have 51 good one left, and I have 1 less card. And when I'm picking the third one, now I have 50 a good one left out of 1 less card as well. So if you type it up, these things, right, then let me try it. 52, 51, 50, divide by 61, 60, 59. And my calculator gives me 0.614059. So you cut it right here because it says percent with 1 decimal. So I need up to 3 decimal place. That changed to 61.4%. And I'm dropping this because that's less than 5, of course. Right? So that's the answer right there. Right? Okay, what about the other one? What about that it's, you know, all of them contains error? Right? So let me give you again a little bit of time. Right? Now that we know this one, the previous example, I think it's a little easier for us to figure it out. Right? So try it right now. Try it right now. First one, or error. First one is error. The second one is error. The third one contains error. Okay. it goes just like that, right? First one that we have 9 errors out of 61. Second one is 8, because we picked the first one as error. Now we have this left, right? And then we have one less card again, and 7, one less card again. So if you let me retry. 9 times 8 times 7 divide 16 times 59. Okay, so my calculator gives me 0.0023339, whatever, right? So I'm putting right here. That's less than 5, so I'm just going to drop it. That's my answer. Change that to that percent. I'm pushing this 1, 2 times right here. So that's why it becomes 0.2%, just like that, right? In here, I'm pushing this 1 and 2 times. That's why 61.4%, right? Just like that. Okay. So, sometimes they say, is it usual? Is it unusual? If it's less than 5%, if you get less than 5% probability, then you say it's unusual. But, this is not even 1%, it's 0.2%. So, which is very unusual case, right? Okay, so that's it. That's the wrap. This is a relatively short chapter, but I really want you to understand and get this one correct. All right, that's the wrap for this chapter.